So now let's take a look at some more of these inverse trig function derivatives on this worksheet here. So let's start here with the derivative of inverse tan of x cubed. Again, this is a simple chain rule argument here. So we've got the inverse tan of something. So if I want the derivative here, I have the inverse tan of something. So remember, I have basically 1 over 1 plus x squared, but where that x squared, where that x and that x squared is really the something for my chain rule. So I have 1 over 1 plus x cubed squared times, go to the side, take the derivative of 3x squared. I'm sorry, take the derivative of x cubed, which is 3x squared. So we end up with 3x squared over 1 plus x to the 6th. Okay. All right, so now if we go to 2 plus x inverse sine 2x. Okay, well, taking our derivative, 2 is a constant, so the derivative of 2 is 0. And then when we get to x inverse sine 2x, important thing here, that is a product, okay, of two functions of x. So derivative of the first is 1 times the second as it is, plus the first as it is, x, and then times the derivative of inverse sine of 2x. Again, chain rule, inverse sine of something. So it's 1 over the square root of 1 minus that something 2x squared times the derivative of what was inside gives us a 2. So we get inverse sine 2x plus 2x over the square root of 1 minus 4x squared. All right. How about the derivative of 3 inverse tan x over 2? All right, so we have the derivative as, so we have a multiplicative 3, so that just stays there. Derivative inverse tan x over 2. Well, inverse tan is 1 over 1 plus x squared, so it's 1 over 1 plus x over 2 squared times the derivative of x over 2. Now, realize that x over 2 is really just 1/2 x, so the derivative is just that 1/2. Okay, so now I have 3 over 2, so I put the 3 times the 1/2, and then I have 1 over 1 plus x squared over 4. Now, I'd probably like to make that look a little nicer. So what I'm going to do is I'm going to multiply this by 4 over 4. And I'll get, so for the constants, I get 3 times 4 over 2. So 12 over 2 is 6. All right, and then I have 1 over, so when I multiply that 4, I'll get 4 plus x squared. So really in the end, I get 6 over x squared plus 4. All right, so our last one here, we have inverse sine 3x over x. All right, important to note the basic structure. We have a quotient rule. We have a function of x on top of a function of x. So the first thing to take care of is the quotient rule structure. So derivative of the top Okay, so that's the derivative inverse sine 3x. So that's 1 over square root 1 plus 3x squared times the derivative of the 3x, which is 3. That was the derivative of the top, all of that times the bottom, x, minus the top, as it is, sine, inverse sine 3x, times, so that's the derivative, so the top as it is times the derivative of the bottom, which would be 1, all over, all over the bottom squared. Okay, so we have, let's clean this up a little bit, we have 3x over the square root of 1 plus 9x squared minus inverse sine 3x all over x squared. And most likely what we do here is we would multiply through by the square root of 1 plus 9x squared over itself to clear that denominator. And so we would get 3x minus inverse sine 3x times the square root of 1 plus 9x squared all over x squared times the square root of 1 plus 9x squared. And there it is. All right, and those are some more derivatives of inverse trig functions.